Okay, so moving on with our and versus or, I want to get to the next thing, which is the addition law. So notice the addition law down here. It's saying for two events, A and B, and notice it's talking about the union. This is or problems. Okay, so if we have or problems, this would be or. So up here in these examples that I have up here, they don't exactly meet the definition of the addition law because I really only have one event happening. I'm only rolling one die. I just have a simple event. But we can actually think about how could I get this answer just thinking about the probability of getting a 2 and then thinking about the probability of getting a 5. Okay, so we're going to go and break this one down, and you're going to see that it has something to do with the addition law down here. Okay, so we're just going to be looking at these OR problems, because the addition law has to do with OR problems. So this problem, and where's my other one? Right here, my OR problem. So if we go back up here and I say, well, what's the probability of getting a 2? The probability of getting a 2 on a die is 1 out of 6. Okay, so the probability of getting a 2 is 1 out of 6. And what's the probability of getting a 5? Well, that's also 1 out of 6. So what can I do with 1 6 and 1 6 to get 2 6? You guessed it, I can add them together. So the 1 6 plus 1 6 equals 2 6. So when we have an OR problem, we can actually use what's called the addition law, because we get to add our probabilities together. We get lots of extra chances, so we get to add our probabilities. So notice when we add fractions, we keep the denominator and we add the numerator. So we end up getting a better chance of winning than if we were just trying to get one of these events happening at a time. Okay, so we're going to skip down here to the other OR problem. Roll a die, find the probability of getting a multiple of 2 or 3. So let's try breaking this down. So if I wanted the probability of getting a multiple of 2, the multiples of 2 on a die are 2, 4, and 6, so that would be 3 out of 6. And then the probability of getting the multiples of 3, well, the multiples of 3 are 3 and 6, so that would be 2 out of 6. But what happens if I add those together? If I add those together, I end up getting 5 out of 6. So 3 out of 6 plus 2 out of 6. That would give me 5 out of 6. So something's wrong here. If I just add these together, I'm not getting my observed probability by looking at my list and looking at how many opportunities I have. And that's because of this overlap. The 6 is the same 6 on here. There's not 2 6s on here. This 6 is repeating. This 6 is repeating on both lists. So I don't want to count it twice. So how do I get rid of it? I get rid of it by finding what's the probability of getting a number that is both a multiple of 2 and a multiple of 3. So we did that up here. The probability of a multiple of 2 and a multiple of 3 is 1 out of 6, because only the number 6 is both a multiple of 2 and a multiple of 3. Okay, and how do I get this probability? If I'm just using my fractions and I'm not actually drawing a list, what I can do is I can say, okay, what's the probability of getting a 2? So the probability of getting a 2 is 1 out of 6. And the probability of getting a multiple, I keep forgetting to say that, multiple of 2 and multiple of 3. The probability of getting a multiple of 2, let me back up, was there were 3 of those on the die, so 3 out of 6. I don't need this 8 or the 9 because they don't occur on a die. The probability of getting a multiple of 3 is 2 out of 6. And remember what we did over here on this side with our compound events. If I want both things to happen, I multiply them together. So if I have 2 6 times 3 6, I get 6 over 36. And what does 6 over 36 reduce to? It reduces to 1 6. So the probability of both things happening has a probability of 1 over 6. So right now I'm stuck down here at 5 over 6, but I want the answer of 4 over 6. I need to subtract off the probability of both things happening. See the overlap? The probability of this answer of both things happening is 1 over 6. So if I subtract the overlap of both of those things happening, I end up with my 4 over 6, which is what I observed from making my list. Okay, so here's the equation. This is what it looks like. So if we have an OR problem, a probability of two things happening, I can use what's called the addition law. I can find the probability of the first thing, add it to the probability of the second thing. Okay, so the probability of a multiple of 2 plus the probability of a multiple of 3. But I need to subtract the probability of both things happening because that's being double counted. And we saw this in class when we were talking about the probability worksheet with rolling 2 dice and that answer that was 11 over 36. And people were like, how'd you get 11 over 36 and not 12 over 36? It was because there was one answer that was being double counted. Okay, here the 6 is being double counted. So the probability of getting that 6 is 1 out of 6, so we subtract that from the probability of getting a multiple of 2 plus the probability of getting a multiple of 3, subtract the overlap, and that gives us the total probability. Okay, so I think I mentioned this in class to my classes that these formulas are in the formula packet, but they're kind of tricky. It's actually oftentimes a lot easier to just draw out your sample space and just count how many possible outcomes are there and how many of them make me a winner. So oftentimes with probability, especially this theoretical probability where we're talking about rolling dice or flipping coins, it's a lot easier to just write out the sample space, figure out what could happen, count up all your possible outcomes, rather than trying to rely on formulas. Okay, the formulas can be a little daunting, a little hard to understand. So if it's possible to draw the sample space, all the possible outcomes, if it's possible to do that, that's really a nice way to go. Okay, it makes the probability questions a lot easier to understand. But this is a formula that applies to a situation like this. So if we have two events happening and we win, if either one happens, okay, just like up here, we're a winner if we roll a 2 or a 5, we can just add those probabilities together. But if there's some overlap between these two things happening, like we had with the multiples of 2 or 3, there was some overlap, you have to subtract off the probability of the overlap, that overlapping occurrence, to get you your final probability. Okay, so that's the addition law. And we'll be practicing that, of course, more in class. All right, take a break, and then we'll do the last page.